Hey everyone, and welcome back to DevOps Corner. Today, we are tackling a piece of tech that has absolutely revolutionized how we build and ship software, Docker. If you've ever muttered the words, "but it works on my machine," then trust me, you're in the right place. We're going to break it all down. And hey, if you're into this kind of content, make sure you're subscribed and hit that like button. It really helps us out. Okay, let's just dive right in, because this quote, wow, it hits home for a lot of us, doesn't it? You've probably been there. In a meeting, people are throwing around terms like containers, Kubernetes, orchestration, and you're just nodding along, hoping nobody asks you a direct question. Well, don't worry. Today, we're going to demystify all of that. So here's our game plan. First, we'll talk about the developer's dilemma. That's our works on my machine problem. Then we'll get into the 3 key ideas that make Docker tick. After that, we'll peek under the hood to see how containers actually work their magic. Then we'll get practical with a 7-step guide. And finally, we'll look at how to handle more than just one container. All right, Section 1, the developer's dilemma. You already know what this is about, don't you? It's that classic, infamous line, you build something amazing, it runs flawlessly on your laptop, and then you push it to a server, and bam, everything breaks. It's a nightmare. The real villain here is what we call environment inconsistency. Your Mac has one version of Python, the production server has another. Your database is slightly different, the dependencies don't match. Docker's solution is genius in its simplicity. It packages your app along with all of its dependencies, the libraries, the runtime, the whole shebang, into one standardized box that runs identically everywhere. So, how does Docker actually pull this off? It's not magic, it's all about these 3 core concepts that build on each other. I like to think of it as a logical flow. You start with a blueprint, you use that to create a template, and then you run a process from that template. And it all starts with this thing called a Dockerfile. Seriously, it's nothing more than a simple text file. Think of it like a recipe for a cake or an architectural blueprint. You just write down a series of step-by-step instructions telling Docker exactly how to assemble your application's environment. Now, when you give that blueprint to Docker, it follows your instructions and builds what's called an image. This is a crucial point. An image is an immutable, read-only template. It's like a perfect snapshot, frozen in time, containing everything your application needs. You can then pass this image around, store it, and use it to create as many copies as you want. And that brings us to the container itself. This is the moment it all clicks. A container is simply a running instance of an image. It's the live executing process. So you use your single static image to launch 1, 10, or 100 identical, completely isolated containers. But what is a container, really? How can it be so isolated from everything else, yet so much lighter than a full virtual machine? Well, the secret sauce isn't in Docker itself, but in some incredibly clever features that are built right into the Linux kernel. It all boils down to 2 main things. First, namespaces. You can think of these as putting blinders on a process. A namespaced process thinks it has the entire computer to itself, its own private file system, its own network, its own process list. It literally can't see anything else. And second, you have control groups, or C groups. These are like putting a leash on that process, limiting how much of the host's resources, like CPU power or memory, it's allowed to use. And that right there, that's the big secret. A container isn't some mystical heavyweight box. It's just a regular old Linux process that has had these 2 sets of rules, namespaces and C groups, applied to it. That's why they're so unbelievably lightweight and can start up in a fraction of a second. Okay, that's enough theory, right? Let's get our hands dirty. Now that we understand what a container is and why it's so cool, let's actually walk through how you can build and run your very first one. This is the path from 0 to a running application. You just need to install Docker Desktop, which is super easy, and then the first real step is creating that Docker file we just talked about. So here's our blueprint in action. This is a pretty standard Docker file for a Node.js app. First, we start from an official Node image. We set a working directory inside the container. Then we copy our package file and run npm install. And here's a pro tip. We do that before copying our main code. Why? It's a caching trick. Docker builds in layers, so it won't have to reinstall all your dependencies every time you just change a line of code. It's super efficient. Finally, we expose a port and set the CMD to start the app. Once that file is ready, you just open up a terminal and run docker build. This command reads your blueprint and creates that static image. The little T flag is for tag. It's just a friendly name so you can find it later. And the dot at the end That just tells Docker, hey, the blueprint file is right here in this folder. And now for the magic moment, Docker run. This takes our image and brings it to life as a new container. The P flag is key here. It's like port forwarding. We're building a little tunnel from port 5000 on our machine to port 8080 inside the isolated container. This is what lets you open your browser and actually see your app running. Okay, running a single container is fantastic, but let's be real. Most applications are more complex than that, right? You often need a web app, a database, maybe a caching service, all working together. And this is where Docker Compose becomes your best friend. Instead of juggling a bunch of different Docker run commands, you define your entire multi-container app in one single clean configuration file, written in YAML. You can see here we define a web service that we build ourselves and a DB service that just pulls a standard MySQL image. It's all laid out right there. And the best part? You just type one command, Docker Compose up, and your entire application stack comes to life. So let's bring it all home. Why does this all matter? It's consistency, which kills the works on my machine bug forever. It's portability, letting your app run on any cloud or server. It's efficiency, because containers are so light and fast. And it's scalability, making it easy to manage even the most complex apps. You know, what this technology really does is it fundamentally separates our applications from the infrastructure they run on. So I'll just leave you with this thought to chew on. If any application can truly be packaged to run identically anywhere, what do you think that means for the future of how we build software? That's our look at Docker. I really hope this helped you get a solid grasp on what containers are all about. If you found it useful, do me a favor and hit that like button, and maybe share it with a teammate. Thanks so much for hanging out at DevOps Corner, and I'll catch you in the next one.